Good morning, everyone. Right now we're going to do part 1 of 5.2. So we have basic logarithms and we're going to go over some inverses. So we're going to split that into 2 parts. So at first, let's just go over some basic logarithms. So we talked about last class that exponential and logarithmic functions are inverses of each other. So the two of the most widely used logarithms are the common log, which is base 10. So when you see the common log here of log base 10, you might just see it as log. So when you don't see the base, it's 10, okay? So that's one of the most common ones. It's on your calculator and everything. And then there's that natural log. So in other words, ln of x. And we talked about this last class. And ln and e are inverses of each other. And your base, let's say base 2 for exponential, and log base 2 are inverses. So you see that connect. So what we're going to do too is we're also going to be converting logs and exponentials and see how they react or interact. So if I look at log, I have log b for base. Log base of x equals a c. Well, if you look at this over here at this exponential, the c is the exponent, okay? So we have b base of an exponent equals x. So we see how we can rewrite these forms. This goes along in connection to ln. ln of x equals c is the same as e to that c, remember that exponent, equals x, because those two correspond with each other. So let's do a little rewriting here. This example 1 here, we're just going to rewrite it in the exponential form. So we're taking it from a log and putting it in exponential. So let's start with our base. Our base for a is 4. And here, what we do is we put it as the base for the exponential. Now, if you look in our exponential, after our base comes our exponent. Where do we find our exponent? Well, it's what our log equals. So our exponent is 3. And our x value, what this equals, is 64. And this makes a true statement. We can even check this out on our calculator. 4 to the 3rd is 64. Let's go to B. Okay, start with that base. That base is 5. What would that exponent be? Remember, the exponent here is on the right side. So the exponent's -2. And it equals that x value of 1 over 25. This also makes a true statement. We talked about last class how negative exponents reduces it into a fraction and puts it in the denominator and makes it smaller. All right, let's go to the next one here. So the base is 65. Ooh, I don't know if I'm going to be able to do this in my head. What's the exponent? The exponent is 0. Oh, I can do this in my head because anything to the 0 is the value of 1. So this is rewriting our logs in exponential. So let's go the other way right now. Let's do our exponential in a log. So of course, the first thing I'm going to do is write my log. And then of course, I subset that base. So the base is 3. Now it's the base and then of x. Well, x values is what the exponential equals. So of 81 equals the exponent, which in this case is 4. Okay, let's do that again. Log base 10, right? So I go log base 10, but we learned up here that we actually don't need to put that 10 there, right? Because if it's out there, it automatically means 10. Of x, so x in this case is 1 over 100 equals the exponent of -2. So guys, if you put the base, log base 10, you're not wrong. You can do that. I'm just trying to get you to be familiar in that connection. All right, log, the base is 6, the x is 6, and the exponent is 1. Let's see if we can do a general. So log, which one is the base in here? Well, it's the m. The x value is g equals the exponent of k. Make sure your bases are down below like a subset so we don't mix up that it's not multiplication. Okay? All right, we're going to go over some basic properties today, and I'm going to add 2 of them. So first of all, we want to make sure the b has to be greater than 0, otherwise we're dealing with a whole different function. B cannot be 1 because 1 times 1 times 1 times 1, right? It's repetitive and it's only itself. And x has to be greater than 0. And c can be any number, okay? So here are some properties that we can look at. Log base b of 1 is 0. And I'm going to prove that to you by rewriting. Okay, if we rewrote this, it would be the base 0 equals 1. And we went over this the other day. Anything to the 0 is 1. So we can recognize that, but I want you guys to start recognizing this one. Let's talk about this one right here. Log base b of b equals 1. Well, how does that make sense? Let me rewrite it. B to the first is b. Well, yeah, anything to the first is itself. So that makes sense too. All right, let's talk about this one. Let's rewrite it. So b to the exponent of c equals the x value. Well, yeah, b of c equals b of c. So this statement is true. So what I want you guys to keep in mind is this log base b and this base b here to this exponential part, they cancel. Why? Because they're inverses. That's why. Same thing down here. We have a base b to a log base b. Well, those are inverses, so they cancel, and we get x equals x. I'm going to put 2 more on here just because the connection with ln and e. So that goes along with 3 and 4, okay? So if we have e to the ln of, let's just say a, equals, well, e and ln are inverses of each other, so they cancel each other out, leaving us with the value of a. Same thing as if we went the other way. ln of e to the a. Again, the ln and e are inverses, so they cancel and we're left with a. So now we're going to use some of these properties to do a through f here. Now, log 10 of negative 4. I'm actually going to rewrite this and say log, because what does no base mean? No base means it's automatically 10 to the negative 4. Now we can relate it to one of the properties up here. So we have the log base and the base being the same. Those cancel. So our value is that exponent value right there, which in this case is negative 4. B, well, that was one of the values up here that I talked about. E and ln are inverses of each other, so that leaves us with 6. 3, or log base 3 of 1. Well, if we go back to this property up here, that makes it equal to 0. D, log base 50 of 50. Those technically cancel, but what's the exponent right here? It's 1. And we can relate that back to that property. All right, here we go. We can relate this to number 4 up here, that property, right? Base 2, log base 2, cancel, leaving us with 32. All right, this one I'm going to have to do a little bit of a challenge here. I've got to rearrange this so that way I can use these properties up here. So what I want you to think about is how can I change 1 over 64 to the base of 4? We went over this on the other page. If you can't remember off the top of your head, 64 is 4 to the third. Now, because it's 1 over 64, that means this exponent must be a negative because it's a fraction, okay? Now this looks like a property that we can use above. Remember, log base 4 and base 4 here, they cancel, leaving us with -3. Okay, this is the end of part 1. So you can stop right now and do some practice on the couple pages down in the packet. They're just your basic rearranging, and some properties of logs. I know it looks like a lot, but hopefully it goes fast.